Hello? Okay. All right, so as soon as Daniel gets the hell out of the way of the projector, we'll go ahead and get started. Okay, so we're going to do just a little show and tell type thing here today, just DIY hardware. What we're going to end up doing is we're going to carve something out into some copper boards, and then we're going to... Oh, I got to get in front of... I don't like cameras. All right, so we're gonna eventually make a little infrared detector, and then we're gonna use this remote stolen from somebody's room to show that it works. So anyway, let's go ahead and get started. And if there's any questions at any time, just throw them out. It's real informal and everything. So, all right. And I'm already screwing things up. Okay. So outline. I don't know. I'm not really gonna go over it. You can read. We're going to make it. It's going to be cool. Okay, so why do you want to make your own hardware? Because, well, it's fun, but more importantly, chicks dig it. And, and you'll impress your friends, but more importantly, chicks dig it. Also, you can do cool things with it. There's a talk on Xbox hacking by Wolfus, I guess, who... I'm sure he'll talk about it, but the original Xbox hacks that they did, the mod chips and stuff, were basically pig chips on little homemade PC boards. And so, being able to make your own hardware that is compact and you can throw into some other thing to make it do what it's not supposed to is, a good thing. Of course, because you can. And lastly, if you really have to ask why, what the hell are you doing here? So, okay, so wire wrapping sucks. Yeah, we've got something here. It's really simple, but I don't know where. See, I don't know if you can see this or not, but this is lame and it's hard to do. And if something breaks, it's impossible to figure out. Yeah, okay. This took him an hour, and if you actually were to make something that was useful as opposed to just something that blinks a light, that would take a long time and be lame. Other ways to do it, which are usually a lot of people know how to do this with breadboarding. It's just basically a big matrix of little holes that you stick wires into and you can connect things to. A little bit better, but this still sucks. It's good for prototyping, but if you slip and pull a wire, you're going to be spending a lot of time debugging, and that's lame. So, wire wrapping and these other methods, they take a lot of time. They're messy. They're complicated. You can make a lot of errors, and they're just generally annoying, and chicks don't dig it. So, PCBs are good for the exact reasons that the other stuff sucks. Also, with PCBs, you can use like CAD design, EDA software to make them, and you can get much more complex designs in much smaller areas than you could possibly do with wire wrapping. Also, they're reproducible, so once you have your cool hack, you can actually make another one, which is nice. Okay, so we're going to go through the list of things that you would need to make one of these. First, you'll need some copper that's copper clad onto fiberglass. This is an example of it. You can buy it at any number of different places. You can get it at Radio Shack as a last option, but there's a lot of online places that sell it. I actually got a lot of it from eBay for pretty cheap, so that's another good option. Yeah. And it comes in different varieties and different copper weights. And in this case, this is actually dual-sided, so you could make a two-sided board if you wanted to put like power on one side and actually the signals and circuits on the other side. And that's what a lot of people would do with the two-layer design. So the real hardcore ones that you'll see, like motherboards, they go up to like 8 layers, and you can't do that yourself, so don't try. You also need something to make hot water. It has to be hot. And we're going to put some etchant into it that's going to eat the copper away. We'll get into it more, but you need a heating element and something to heat some water in. You need a wire brush, steel wool, something like that, and you'll need a drill and a Sharpie to actually draw your circuit. So safety glasses are good so that you don't go blind. Latex gloves are good, and other stuff. At the end, I'll talk about a different way of doing it where you actually transfer something that you've printed out. So for that, you'd need a laser printer and some transfer paper and an iron. So the other thing you need, of course, is actually a circuit that you want to create. In this case, we're gonna show a design for a simple little IR detector that you could use for any kind of remote. And I already talked about that, but it's really simple. It only takes a couple parts: a photodiode, a transistor, a resistor, and some sort of power source. So we'll show that at the end, and you can check it out. All right, so this is the circuit, and basically how it works. I don't know how many of you know much about circuit design or anything like that, but this is really quite simple. You've got your battery right there, and you've got a transistor which essentially works as a switch. This is a photodiode which basically lets current conduct whenever it shines light on it. And over here you've got an LED that'll show you that it's turned on. And this resistor just limits current so that you don't have what looks like a short circuit. So in your schematic capture utility, you would draw this thing out, and then you could switch to a PCB layout. And this is an example of something that you could actually print out. You would first print out just the wire here, the blue and the green, which would be actually what you would transfer onto the copper, and then you can silk screen over it if you want to be really fancy. But it's a really simple circuit, and yeah. All right, so the first thing, we'll go ahead and start the demo now. The first thing you got to do is you got to clean the copper board because it oxidizes, and that makes it harder to etch. So use your steel wool and just clean it off.
If you don't do this, this could take a long, long time.
I'm only going to do one side because we don't need to do two sides for this. And I'm not even going to actually make a circuit here. I'm just going to write Phreaknic on it. All right, so the artwork, this is actually, sorry. So this is just something that I pulled from somewhere. This is the actual artwork from the board that we created that I'll eventually show you as it was etching. It's blue because we actually took it while it was etching, and you'll see that the water will turn blue as the copper gets dissolved and goes into solution. So after you've cleaned it off, you want to go ahead and write whatever you want to write in it. So I'm just going to write Phreaknic on it, and I'm going to go ahead and start It doesn't really matter. You just need enough. You just need enough so that the reaction. Sorry. Yeah, you just need enough so that the reaction happens. Some places will tell you 1-to-1, but that's really too much. You can just kind of eyeball it. If the reaction's not happening very well, you can just dump more in. It doesn't. This doesn't need to be an exact science. So, I mean, it's a hacker conference. We just kind of hack things together,
Also, if there's some sitting in the bottom that's not dissolved, you should probably stop. Not even dissolved yet.
it's actually really pretty simple. I mean, if you're doing the Sharpie method, which is what I'm doing right now, I'm just going to write onto it. It's really pretty straightforward. The only thing I guess I could say is that you want to make sure that your ink is really thick and uniform. If you don't, which probably will happen in this case, what'll end up happening is it'll be a little bit pitted. With the transfer method, it's better. I mean, Sharpie is good enough for hacking purposes, but if you're actually going to do something seriously, like you wanted to sell it or you wanted to show it off or something, you would probably want to do like the transfer method that I'm eventually going to talk about. But it's, like I said, yeah, it's really pretty simple. It's really pretty simple to do. It's just if somebody shows you how to do it, that's pretty much all you need to do. So.
You also might have a problem with over etching. The first example we did, man, that was worse than I thought. Yeah, we had a really bad problem on this one, especially with not enough ink and getting some really nasty looking etched copper. On the back, we wrote our names. You can see they're completely gone because we left it in the etchant too long, so they just kind of disappeared. If you want to etch two sides, you have to set it on something so that it gets even etching on both sides. It's a little harder than just one-sided because you can just dump it in the liquid and let it go. But that was kind of difficult.
Okay, so I just so there's two different kinds of etching that are common. There's one which is sort of this. It's ammonium persulfate, also an eBay purchase. Easy to get online. It's safe. You can dump it on the link. And it's clear, which is nice. The other type is ferric chloride. It's dark brown color.
Yeah, you can't touch anything with this, or it'll stain concrete. It'll stain a stainless steel sink. It will stain anything, so don't use it. Use this.
Yeah, so in order to have to actually keep it hot, which is not necessarily a requirement of the ferric chloride, but keeping it hot will help. And if you really want to get slick with it, you can get like a bubbler, some type of like a fish tank bubbler or something that will actually create bubbles around it, which will help speed up the reaction. But heat is good. So well, you don't want it to be boiling, but you want it to be pretty warm. The guideline, what was the guideline? 35°C, something like that. Anyway, not too hot, but again, like I said, just make it up as you go. It'll work fine. This is not an exact science. So while he's dumping more etching into there, we're going to keep going. It usually takes it can take up to 15 minutes or so for it to happen, and it'll happen pretty slowly. But once it starts, it'll move along. But we'll show you how that as it goes. Yeah. The steaming is from the water, and it's just the water. I wouldn't worry about it. Okay, so this was one that we did before. That's the one that I've already sort of showed you. I don't know, it's too dark in here probably to see, but we did it Hello World in paying homage to every programming language ever, and you can see the two next to each other. So. Once the etching is done, we're gonna go ahead and go on while that's going. But once it's done, you'll take it out and you need to rinse it off so that it doesn't, so that the etching doesn't recrystallize back onto the board. If it does, it's not a big deal. You can use a solvent or something. Probably some of it will crystallize anyway, but washing it off is a good thing to try to minimize that. And also, if there's a lot on there, it'll be a lot harder for the solder to stick to it. So you want to make sure to keep it as clean as possible so that soldering is easier Once you're done with that, you can do your drilling and all this stuff. I mean, should be pretty straightforward. Solder your parts on after you drill it, and project over, you win. So for printed, okay, so now we're going to talk about the printed transfers. Basically, with this, it's kind of cool. As it turns out, like the toner in laser printers is made out of a lot of plastic, and so what you can do is if you take like a photo paper seems to be the best, or you can buy specialty paper, but that costs more money. You can print onto it. Usually, if you run it through the printer 2 or 3 times to make sure you get a good thick coat on there. What you do after that is you place it face down on the copper after you've cleaned it, and you just iron it on, and you melt the plastic right onto the copper, and then after it cools down, you can put it in water and try to get the paper off as much as you can, clean it off, and it'll leave the plastic behind, and it'll make nice thin traces, and then you go through the etching steps as however you normally do it, and at the end you can do much finer type work, and in a much smaller space that way. So that's a good idea. Okay, so just a word about EDA. EDA stands for Electronic Design Automation, and these are some options that are out there. There's Express PCB and PCB 123, which are Windows, and they're free. You can go download them. You can draw your schematics first, and then you can switch over and lay out your board. And then once you're done with that, you can actually just click send. It'll actually give you a price estimate right on in the program, and you click send, and it'll go to the manufacturer, and they'll print them up and send them to you. Usually, when you do that, they require you to buy 2 of them, and it usually costs anywhere from $70 to $100. So, making them yourself is better, unless you're doing something that you really need, to try out in a professional sort of way. There's also an open source project called GEDA and X-Circuit, which are also, there for layout and stuff like that. And the one that I usually use, the one that the pictures from before were created with, is this program called Eagle. And you can download it. There's a demo that comes with it for free that is fully functional, and it works really well. And if you want to get a bigger PCB area, then you need to pay for it, or whatever other method you might have to not pay for it. So anyway, and then there's the big boys tools. There's ProTel. There's the OrCAD tools. There's a bunch of these ones that are really overkill for most things that people are going to be doing, but whatever. Okay, so parts. I'm sure you all know about this, but Radio Shack is a last resort. You've got questions, they can't answer them. So, yeah. So DigiKey, Mauser, local electronics supplies stores, whatever. Radio Shack if you're really in a pinch, but they're not helpful. So, what's that? That's true. They do. He says they certainly think they are. They'll try to make something up if they don't know an answer. That's definitely true. They will sell you or a compact computer. So we're gonna, while this thing's still etching, I don't know if you can see from far away, but it's starting to turn blue a little bit. The reaction takes some time to actually go to completion, so we're gonna keep going with that. But I'm gonna show you this circuit. Let me put the actual schematic back up on the screen here. It really depends. In the case of this stuff, I actually looked up online to see, and they said that this stuff is okay to pour down the sink. If you can't do that, I don't know. Maybe take it to a local high school or university that has a chem lab, and I'm sure that they'd be more than happy to get rid of it so that you don't have to pollute and stuff like that. Yeah. That's a good point. Yeah, that's a really good point. We actually, usually when I do it, I just dump it down the toilet, and I live in an apartment, so yeah, an upstairs apartment at that. That's true. So this is actually the circuit that I already talked about, and we've actually created it here. And I don't know if you want to come up and look at it, or I can pass it around. But I'm going to actually go ahead and just show you how it works. Basically, this clear diode right here is the photodiode, and so when it gets light, it will conduct current. So this is actually, if you look at the tips of IR devices, it always has like that clear tip on it, and that's actually just an LED basically, same as this. And then we've got a red LED here and a transistor. So, and I don't know if you can see the artwork on it. Like I said, I'll either pass it around. This is a really, really simple circuit, but I mean the point was just to show that you can do it, and it's good. So I'll go ahead and plug it in, and then I'll point this at it. Now it's a little bit hard to see because this has a pretty wide spectrum that it reacts to. If you were going to do this really nicely, what you would do is you would get like an IR filter that you would put over it so that it only passes IR through, and then it would be the LED would be totally off until you pointed an IR device at it, and when you press the button, you'll see a flash. The other things is for those who don't know how the remotes work, they actually just basically send a square wave, 40 kilohertz I think it is, and it's got a pattern that the receiver can detect, and then do the corresponding action too. So let me go ahead and plug this in, and I'll just show you how it works.
And this was a lot cheaper than buying one of those phosphorescent infrared detectors from Radio Shack. Those are about $15, and it's a little piece of paper practically.
So yeah, basically, from that, obviously you can see that you can get your signal out of it, and then it'd be pretty easy to go from there to plug it into like a parallel port, and then you'd have basically an IR detector that you have to write your own software, but that's fine. It's not that big of a deal. And so that's pretty much it. This thing's still going. Is there any more questions about it, or we're just gonna let it go? Yeah. I've not tried the real ones before. I've used the other ones, and they work fine. It depends on how small your traces go down to. If they get really small, it's going to be hard to transfer them properly. It kind of depends. I mean, it's really just at this point it becomes more of an art than anything. It's just kind of you just got to kind of finesse it. And if you do get a little bit of broken traces here and there, you can always jumper over it, which is totally valid. It still sucks less than wire wrapping. So yeah. Well, I guess I haven't really made too many circuits that I care that much about, but yeah. Usually I just I'll make something little and just to prove that I can and things like that. But it's really you could code it with something. I'm sure they're like at the hardware store. Once it's all laid down and everything, you're good to go in that sense. Yeah, I mean you could basically just code it with you could put wax over it even if you wanted to, as long as it wasn't something that was going to heat up. Is it? Okay, yeah. So I mean, but really, that's not really going to be that much of a problem. I mean, even if the top of it oxidizes, there's still going to be plenty underneath that. Assuming you don't have some really, really cheap, really thin copper board, there's still going to be a lot of conducting underneath. So I don't think that should be really too big of a problem, especially for the do-it-yourself type stuff. So yeah, is there any other questions? Yeah. What others? I've done some stuff like for projects here and there. Like I did this one project that I had to do that would basically follow a line. It's called Blinky. I don't know if there's any Vanderbilt students here, but basically it follows a line and it records where it goes. Then you can go back and play it back, and it will walk back around the line even if the line isn't there. So it uses a little IR detector to see if it's on the black line or off the black line, and so it'll walk around that circle and it'll record it, and then it'll go back. That's probably the biggest project. I mean, like I said, most of the little things that I do are just, I wonder if this will work, so I'll just do it and see what happens. Yeah. Other questions? Okay. Well, that pretty much wraps it up. If you have any other questions, I should also plug this. I don't know. There was somebody here who I saw this on their website, and I apologize for not knowing who you are, but it was definitely one of the Phreaknic people. But they had this idea for hacking or taking apart a. What's your name? What's that? Shadow. Okay, so that's right. So I caught it off of Shadow's website, but I ended up making my own because it was a really good idea. You can just take any PC power supply and hack it up to make it work as a general power supply with a whole lot of current in it, and so anytime you need 30 amps at 5 volts, right here, so that's pretty much it. If there's no other questions, feel free to come up and ask any questions whenever. I'm only going to probably be here for today though, so whatever. Anyway, thanks a lot, and yeah.